All right, so sweet. All right, so tonight we are talking about building complicated systems with domain-driven design. I'd actually talked to Levi last weekend. We This is actually going to be part one of part two. Part one, we're going to be talking more or less about the theory and implications and of how to build large systems with domain-driven design. And then part two will be the implementation details from a technical perspective. So let's get started. Hi, I'm Fred. I am the co-captain of Open SGF, which is a Code for America brigade. I'm also a founding member of Springfield Devs. I don't participate with social media, so this is a link to my GitHub page. All right, so complicated projects. So these kind of mean different things to everyone. So it's a pretty subjective term. So what we're going to say tonight is we're talking about projects that require a highest degree of communication. This can come in forms of people-to-people communication or application communication or application-to-application communication. So tonight, a complicated project is not a CRUD application, not an extract, transform, load application or ETL, not a web application front end, nor a thick client desktop, and by thick I mean THICC, and not an application developed by a single team. Instead, tonight a complicated project is one that consists of two or more of the above applications working together, or one that consists of two or more teams working together. So really, the way I define complexity is, multiple systems that involve communication. This could be from teams to applications or teams within applications. It doesn't matter. The moment you add people, the moment you add projects or add features to your project, the more complicated it gets. At least that's my opinion, and that's what we're going to be talking about tonight. All right, so domain-driven design at a high level. Oh, wait, I skipped a slide. Domain-driven design at a high level. It's a methodology for managing complicated systems. So, it's one way to think of this as not a framework of like MVC or an architectural framework, which I guess is also MVC, but it's not proper to think of it that way. It's not proper to think of it just as agile either. It's more proper to think about it as like an overarching umbrella over a multitude of technologies, from agile to object-oriented programming to teamwork, to refactoring, to business modeling, to, that's the whole turtles all the way down. So, domain-driven design is a methodology for managing complicated systems. Eric Evans pioneered the methodology via personal experiences and the study of software patterns. His book, Domain-Driven Design, is a collection of his experiences and experiences of others to cohesively develop a solution managing software complexity. The interesting thing about this is that domain-driven design is comprised of these core tenets: business modeling, teamwork, and refactoring. It sounds like I'm reading from a script, and that's because I am. All right, next slide. Technology. When we dive into domain-driven design, there's a lot of emphasis on object-oriented programming. And this is because as we view the world, we see it as a collection of objects and relationships. Some things cannot be adequately described as objects, and that's okay. And what I mean by that is when we're thinking of like a bird, for instance, we can describe a bird as an object, but the act of flying is a functional aspect of the bird. So, however, the fact that a bird can fly means we can say it has a descriptive property of can fly, and we can correlate that, and we can relate that to other birds. So that's kind of like the difference here is like, you can have, there is a strong focus on objects, but there's also like functional aspects as well. As we'll explore later with bounded context, we can leverage procedural or functional systems within our domain. Buzzwords, but we'll get to that. Domain-driven design does borrow some concepts from functional programming with an emphasis on side effect-free functions and immutability. Lastly, UML is popular to communicate relationships with business. So throughout this presentation tonight, I will be drawing on my Bamboo Pen and Touch from a long time ago, and that's how I'll be showing some of like how UML can be used to communicate some of the concepts. So why don't we dive into a little bit about these technologies? So I know I said there would be no code, but I lied. I said this earlier in our SGF Devs conversation for those who are just joining Twitch. So let's look at what a side effect free function is, because some people may not fully understand what that is. This is this code right here illustrates this concept. So when we talk about side effects, we talk about mutating some state outside of a function. In the first block, from lines 1 to 14, we can clearly see that we define an object with the property name, define that as Fred, and then we have a method. Think of it as a method. We have a function of that takes in an object and sets the object name to that new name. This is a side effect. We are mutating an object outside the scope of this function. Let's talk about the not side effect way of doing this. So those who are familiar with React might be more comfortable with this way of doing it, where you pass in an object, copy it, and then mutate it. So this is where immutability and side effect free functions come into play. We are mutating an object, but it's a new copy of the object and not the original. So lines 21 through 32 correctly illustrate a side effect free function. So when we talk about domain driven design in terms of functions, in terms of functional programming, they really, even though it's more about like object oriented programming and it's thought about in terms of object oriented programming, the implementation, you want to strive for immutability and side effect free, because when you're working on large and complicated systems, and especially when dealing with communication, you end up in a situation where you're dealing with a lot of threads, or not necessarily threads in general, but like let's say you have more than one client talking to a database. You're going to introduce some sort of race condition with mutating that data. So copying is a very effective way of making thread safe, that's the word, thread safe functionality within your application. There's also other ways of doing it, but I'm not going to go into details. But just keep in mind, when we're working with domain-driven design, we want to try to design our functions with side effect free, and we want to try to utilize copying as much as possible. All right, so let's go here. So did I miss a slide again? No. All right. So let's talk a little bit about ubiquitous. Oh, I could have sworn I had a different slide there. Sorry, I am sorry. I didn't prepare. Okay. So another core tenet of domain-driven design is ubiquitous. Is a concept of a ubiquitous language. It's a fundamental to projects' success, because developers and domain experts, the people who know about the business, need to communicate with one another. And as a little backstory, at my job, I was tasked to design a system to manage our payments and vouchers. At first, I thought calling them benefits because these were payouts for claims. So I work in insurance, so when we think of claims, a benefit would be paying out that claim. Well, it turns out that that's actually incorrect. That's actually the incorrect thought of what it should be. I didn't fully understand what the business was trying to convey. So a more appropriate term for benefits instead is payments and vouchers, because the domain we're solving for has to do with organizing payments than to send them to claimants. Claimants being users who get paid, essentially, people who submit claims to get paid. This language does not develop naturally. It becomes developed through consistent communication. So really, when we try to apply this in your in your business, you really want to sit down with the people who are with the people whose problems you're trying to solve. Sit down with them and really try to come up with a universal language of communicating with one another. This is super critical. I've seen this personally, where a simple word changes how we think about the solution to the problem. So it's a very powerful concept. Okay, next slide. So another way to get started real quick is to, I think I definitely missed a slide. I could have sworn I missed one, so I'm sorry. But another way to start getting involved with your business to really implement and drive this and get this process going quickly is to identify what your actual core domain is. So I work in insurance, and our business performs these functions. So we create products, sell policies, process claims, integrate partners, and we do a whole bunch of other things. But out of our business, what is our core function? Well, we think of insurance, we think of submitting claims, processing claims. Well, while this is true, claims do not actually make us money. Selling policies makes us money. So I can adequately say that, that our core domain in terms of insurance is actually selling policies. So with that in mind, here's my helpful ways to identify this. We want to communicate with your domain experts. So this is where the ubiquitous language comes into play about how your company makes money. Figure out how your current application or future does achieve what it does. Like how would you, figure out what your current application does? Is essentially what I'm trying to say there in a long-winded way. And then write a mission statement. I'll talk about that in a little bit, or not a mission statement, vision statement. I'll talk about that a little bit more next slide, but I think that's a really interesting concept. And then to collect objects, services, and isolate them from the rest of your system. So what I mean by that is when we're looking at our code, we can actually figure out, based on our different modules and our different classes, services, and objects, we can kind of start to draw lines in between them and to kind of figure out which core objects are important versus which ones that are not. And that's going to touch on bounded context, but let's talk a little bit about our vision statement first. So our vision statement, Eric Evans specifically calls out the need for a vision statement in his book because they can be used to inform the project about how to make decisions regarding the core domain. So, for instance, the model can represent customers' products. The act of customer purchase leads to a solid policy or sole policy. Therefore, our model is tailored to a customer. To facilitate tailoring, our products are matched to customers based on their needs. Different models, such as invoice, are stored for record bookkeeping. Lastly, the model should integrate into existing bookkeeping software. So there's a lot that we can kind of unpack, with this particular vision statement. While it's not the best in the world by any means, it's just a quick crack at it. But we can kind of see how we can go about our core domain or how it can dictate our core, or how we develop our core domain by limiting us to what our vision of this domain really is. So when we say this model can represent customers and products, we're describing maybe various classes within our model, how products relate to customers, how policies relate to products and customers within that model as well. And then how can we tailor our policies to our customers? So that might imply some sort of matchmaking match system within our core domain that we want to kind of utilize. This could be algorithms, this could be trivial database lookups, this could be anything, right? The point is we're using this vision statement to identify what we can, or to limit, and also not limit us to figure out what we need to do for our core domain to make sure that it's usable for our customers and to us, so we can actually develop and design these things. All right. Bounded context. So this is the big one. So I'm going to switch to my drawing mode here. So give me a second to get that set up. I just have to click a couple of things. All right. So it might be helpful to at least go into what a bounded context is. Sorry, my mouse is all over the place. It's hard to see it here. Okay, so it might be helpful to first talk about what a bounded context is. So a good analogy to a bounded context might be a microservice. So you have microservice over here, you have a microservice over here. Notice that there is a gap between the two. Microservices can actually kind of be described as like an extreme form of a bounded context because each describes a subset of the system of a whole. So, if this is authentication and then this is user management, these two things are discrete but can be scaled out horizontally as much as needed, depending on your load. It's a very extreme form of a bounded context. But what about a monolith application? So when we think of a monolith, we have user management and auth, and within the same context here. But that doesn't mean we can't split them off into their own bits and pieces. So you can kind of see that there is a little bit of a parallel between microservices and then monoliths within terms of, I think it's called like service something architecture, but within a monolith application, it's kind of like you effectively achieve the same thing with microservice. The only difference is that you scale the whole thing out horizontally versus individual services out horizontally, right? So the last two slides were about identifying our core domain. So our core domain actually exists within its own bounded context. So let's see here. Let me go to draw or file. Nope, not that. Okay, so right. So so our core domain. So when we think of that, so based off what I was describing with my core domain, we have the concept of a product. And then we have a concept of a customer. And then we have the concept of policy. And then we have our bounded context, which kind of surrounds those different things. So we can say that a policy has a product, has a customer. With policy being our main entity, if you will, of our core domain. So our core domain is a bounded context. We're separating this from users separated from auth. Now you might be thinking, well, how do we get these two things to communicate? So there's actually there's actually various strategies for achieving this. But one thing I did leave out before we dive into those strategies is, when we're thinking about our systems, it's kind of helpful to, even though I'm terrible at drawing here on this pen and touch, I'm way out of practice, it's still helpful to sit down with your team and to, just draw out what you have, your current classes, and then just start drawing these squiggly cloud bubbles around them and say, this is our domain, for our various solutions. And once we're able to identify what these bounded contexts are, we could probably say, well, maybe customer belongs in user. And then we can kind of refactor our system from there. So this is like a huge step towards implementing domain-driven design within your organization. The book highly recommends like this being one of the first things you do, create that vision statement, and then drawing bounded context around your current system. All right, so, with that said, it's time to actually talk a little bit about what our translations or our layers are for in between our bounded context to actually to achieve our communication between them. So let me switch back to my stuff here. It's a little fiddly. All right. So there's a couple of ways we can go about this. We can start off with our bounded context by introducing a translation layer or an anti-corruption layer to help facilitate that communication. I'll get back into the drawing here in a second, but primarily a translation exists within a bounded context, and this could be the form of a mapper or other such objects. However, sometimes it may make sense to establish a hard layer between two or more bounded contexts, and then these are what are called anti-corruption layers. So let's switch back. Do a new one. So the interesting thing about these translation layers is we can really use them to segregate functionality from legacy systems and kind of integrate them into the new system. So let's draw that out. All right, let's see here. So when we have our legacy system, we'll just call that L, and then we have our new system over here. We'll just call that N. So we need to communicate with L in some way. So one strategy is to introduce a translation layer in here. So we would have a class, we'll call it T, but it's probably more likely going to be a repository. Oh boy. And if you guys aren't familiar with that term, repository is just a fancy way of saying this is a class or a service that pretty much has access to the database or some persistent storage or even in-memory storage to pull information from and then to direct it back into our applications. So when we look at a translation layer, what we're really talking about is adding classes to a pre-existing bounded context. So that way we can translate between our new layer or our new bounded context or our new system with the old. Now the problem is, and some of you may have noticed this, is that we are adding classes back into our legacy application. Sometimes this is not ideal, and that's where, or not even feasible, and that's where that anti-corruption layer comes in. So if we have a look at that, draw. All right, so let's get back to it. So this is our new, and this is our legacy. So an anti-corruption layer actually sits in the middle. This would be a new bounded context. So old system communicates with that, new system communicates with that. And the way this works, or is commonly implemented, is that the anti-corruption layer may have a lot of facades, or it may have a lot of adapters to really adapt one bounded context to another. I'm using legacy here specifically because this is a presentation on how do we get started. So let's assume that our current applications are all legacy. So when we look at this, we introduce a whole new layer to help these two facilitate communication. Now, the problem with this is the hard way. The previous translation layer was actually the easy way. More often than not, we're going to have the ability to add in translations into our own legacy. More often than not. The problem becomes when L turns into a library. We don't have access to libraries. So in that case, we do want to introduce an anti-corruption layer to kind of communicate between these two. And what I mean by library, I don't necessarily mean just like library. I could mean like some sort of API or some other service like Twitch. Like if we want to integrate with Twitch is our library that we're integrating with. We don't have control over this, so we have to somehow map Twitch to our new system. And that's where anti-corruption layers come into play. Eric doesn't really recommend these, just for the case that these are definitely the hard way of doing it. So they take the most time. They could be the most complicated. Just much easier to stick with the translation layer. All right, let's see here. Go to draw a new. Be nice if this just had like a button I could push that just does things for me. And then let's talk about the last way of doing things in terms of communication. So we talked a little bit about translation layer and anti-corruption layers. So shared kernels. Now, I literally chose this slide and picture because of PowerPoint design ideas feature, and I thought it looked really cool, but it also really gets the point across. When we're thinking of a shared kernel, we were thinking of something that all of our systems have an implicit or explicit dependency on. So when we think of our node modules, or not necessarily node modules, but even like Composer and PHP, when we kind of look at our library package managers, we're introducing all these libraries into our system. We can all think of these libraries this layer as a shared kernel. So this is actually, so let's just go ahead and do another drawing of what this might look like. So when we have our bounded context here, shared kernel would be looking like this, where inside these spots right here, both applications have access to the exact same code. Well, anything in here has access to that, and anything there has access to that, but the whole thing has access to everything. Excuse me, I'm still trying to learn my my join, left join, right join, outer join, all the other joins. Um, when we think of a shared kernel, this is what it might look like. But we have to keep in mind though that shared kernels do introduce that library problem that even Node Modules, Compose, or any other package manager introduces into our system. So we do have to be wary of that. Another caveat though to these shared kernels is that they require a lot of communication. Oh my gosh, I'm having this problem at work right now. We have we have so many different repositories all littered about, and we're trying to introduce these shared repositories that each of these can access. Well, as you can imagine, like if you're trying to add code to this, you pretty much have to get an agreement from all these other people, because one change here breaks all of these. Now, there are ways to protect against that with versioning, right? But the problem with versioning though is that these may become out of date. These repositories over here, and when those become out of date, these may try to do functionality with the shared kernel that these are not ready to handle. So even though there is still like a version mismatch, it could still wreak havoc within your application. So when we're talking about shared kernels, we have to be really careful with how we communicate changes to them, and when we do make changes, updating the dependencies, and then to also make sure that whenever we do these shared kernels, that whatever is agreed upon is fairly set in stone. But let's kind of look at but the interesting thing about shared kernels is that even though they're a strategy to communicate within multiple bounded context, or within multiple different pieces of your system, we can also have a shared kernel within your bounded context. So you can have multiple shared kernels. So we'll call this B, S, and then S, right? So we can have multiple shared kernels littered throughout the application that serve different purposes. So within this context, this shared kernel exists only within here, while this one exists between multiple bounded context. All right. Published language. So this strategy is everyone is probably most familiar with this one. I may not everyone. Most people are most familiar with this one. So another strategy for sharing information, and this is kind of popular among microservices as far as I know, and that is to use what's known as a published language. So Eric introduces this concept of a published language, which could be XML, SQL, JSON, HTTP request. It doesn't matter. It's all about establishing some language that you can communicate between multiple bounded context. Excuse me. I'm not saying that this is necessarily the best way to do things either. And based off what we've seen, if anyone's ever implemented an API, well, we all know how much trouble that is. So, maybe it might make more sense to introduce translation layers instead within your bounded context than to rely on this. And even in terms of microservices, you may want to just reference your microserver projects. I mean, sure, they're their own repositories, so and they may exist in the cloud, each on their own instances, but you can still share the code. You can still treat it as a library. It's just not the same as a shared kernel, but you can still have access to that translation layer. But if you're like most people, you just create a web client that does this translation for you through JSON. And for the non-faint of heart, you could always try to introduce your own protocol. Only do that when it makes sense. Yes. So Levi just asked me if Laravel is a good example of a shared kernel. That's an interesting question. I'm not touching upon this in this particular presentation, but when we're thinking of architectural frameworks, what we're really thinking about are infrastructure layers. So shared kernel, yes, but within a bounded context. Well, I mean, if we're thinking about a monolith application, it's obviously shared amongst all the things. So in my opinion, it serves as a shared kernel. I would definitely say for sure, because it is a library, it is something you're using, but it's also your infrastructure piece as well. So it's kind of a good mix between the two. I would agree with that. All right. Let's see. So an even quicker way to get started. We talked a little bit about like divvying up your application, establishing libraries, establishing communication layers. But what does this actually mean in terms of like technology and code? Even if you can't communicate with your team, even if you're working in silo, you can obviously get started applying DDD today, just by simply introducing value objects, composed entities of values, composed aggregates of entities. So what I mean by this is value objects. Well, maybe it's better to explain it this way. In the world of programming, there's a term called primitive obsession, which essentially means that people or developers or programmers will more or less use primitives. So int, string, float, double, and if we're talking in terms of like some languages that support it, unsigned integers versus signed integers, things like these are all examples of primitive types. What we're saying by value objects is we're saying we're going to add an abstraction on top of those. So when we mean value, what we really mean is something of value. I know that's recursive, but to give an example, an email. An email's primitive type is definitely a string, right? It's an array of characters. But does an array of characters necessarily mean whatever we're looking at is an email? No. So what we do is we create these objects called value objects that kind of wrap around these primitives, and we can apply validation on top of them. So now we can say that when we construct this object, we indeed have an email, because at time of construction, we can say, is this a valid email? Yes or no. If not, throw an error, do something. But but in terms of the rest of the application, we see this as an email. This is a very good strategy to clean up your code. There is a challenge though with this with this approach that I'm learning the hard way about, is that when we talk about CRUD applications and validation, like receiving input from the front end or from any sort of client into our backend systems, or even in between systems, we have this problem of validation, and sometimes we may use a validation framework to validate these things. Those frameworks can work, but I implement them in such a way that they exist within the value objects themselves, as best I can, because what ends up happening in your system, you may have multiple validators for the same thing. So, thinking off the top of my head, what if we said emails we don't care if emails have a plus sign in them, for instance, anymore. Because before, our email validator said no plus signs allowed, but now we want to allow them. How do you figure out everywhere in the code base to update that? How many times have you duplicated code to add those validations in? Does your validation library even allow you to specify these in a single place and use them throughout, right? So introducing value objects is a very powerful tool to limit the validation to the object you're trying to make right then and there. I just realized this would be a good spot to show code. But sorry, not much tonight. So those are values, but what do I mean by compose entities of values? So let's go back to our drawing. OneNote. All right, let's see here. Go to view. You know, if I was actually watching myself on Twitch, I'd ask Twitch channel, hey, is there an easy way to do this? Okay, so we're drawing. All right, so when we think of entities, we can kind of look at them as straighter boxes. We have so when we think of entities, they're a collection of values. So but the distinction between an entity and a value is that an entity has some form of an identity. So we can say that an entity has an identity. And when we compare entities to one another, we'll just call this E2. When we compare entities with one another, especially for equality, we're comparing them on the ID. So not necessarily what information these entities have, but on their actual identification. And so when we do an equality check, even though these values may be different, as long as the ID is the same, we're going to say that these two entities are the same. So entities have identity. One thing about value objects that I forgot to mention is that we want to actually keep value objects immutable. So copy on write, or copy on mutate, or just copy in general. Don't actually edit them. Just like when what I mean is when we have like that email, and then we want to say like set email, and then pretend I'm writing off to the side there. This returns a new instance of email, so that's a copy on write. So entities are actually, we can think of them as mutable. So when we compose an entity, we compose them of multiple values. So email, phone, phone number, etc. And we could be describing a customer. So an entity could be a customer. They have an identification, and their values are email, phone number, and they can be mutated. Sometimes that may not necessarily be the case. Sometimes we may want to actually introduce invariants, which are the fancy way of saying that in order for a customer to exist, a customer must have an email, must have a phone number. So when we create the object for customer, we can't create it unless we have these things already. But the interesting thing about entities in terms of values or in terms of domain-driven design is that we actually want to put behavior on our actual entities and our value objects. Now, in my experience, putting behavior on value objects hasn't really yielded too much of a benefit so far. I haven't come across any cases personally of where I've actually benefited from that. I get most of my benefit from adding behavior to our actual entities, and this could be, and I don't mean set email necessarily. If we were going to change the email, typically you would see something as set email. Right, and then we have the email that goes into it. Instead, what I mean by of behavior, we could rename this as change email, and then pass in a new email. I know there's not much difference here between these two, between the functionality of these or the names of these, but but when we say we're changing an email, we might be implicitly firing off an event, saying that from change email, we might be saying, customer, 1 email changed. and then sending that off to another system, right? So this is the really interesting thing about domain-driven design, is that when you start thinking in terms of behavior and what your actual objects are doing, you begin to realize that there's like some interesting things that you can do with implementing event sourcing systems or even event systems. Even if not event systems, we can turn a result. We can say that this email is already taken. Now, in domain-driven design, those are introduced as policies. So you'd pass in a policy with the change email. And then what we would say is, change email, pass in this policy, change email, and then the policy would be like, policy dot, can, or no, policy is same. And then you pass in the email to that. And then and then the change email can do a check against the policy, which could contain a repository to check to see if the email is the same, and then return maybe false or some sort of a result that the email didn't actually get changed or did get changed, however you want. So when we're thinking of domain-driven design, we're thinking about behavior on our entities. We were thinking about value objects and immutability. We were thinking about collections of entities working together within a bounded context and then sharing their information between multiple contexts. And that's kind of like the big picture of domain-driven design. But we can take this abstraction one step further. Surprise. We can now introduce the concept of groups of entities. And in domain-driven design, these are known as, these are known as aggregates. And then aggregates themselves are entities, so we'll just call this E1. But the interesting thing about aggregates is not only are they entities, but we also have collections of entities that these may establish relationships with. So if we say that this entity right here is like a itinerary. Oh no, not that one. I'm sorry. This one's the itinerary. My bad. Here, let's just draw a new photo, new picture. So we're gonna have the itinerary. I can't spell, so just pretend that says itinerary. And then we have, we can imagine this as like an array of, say, events. Or maybe not events. maybe a better word would be like an itinerary of meetups. So we could say that this itinerary has a collection of meetups. And then we can apply behavior on the actual collection itself. So a meetup is an entity in its own right, with its own identifier. Now, the interesting thing here is, for those who have worked with repositories, or even data access layers, DALs, at some point you're going to need to make queries to pull this information from persistent storage. In domain-driven design, what we might do instead is, instead of having a repository per entity, you have a repository per aggregate. So aggregates don't necessarily mean like you have to have a collection of other entities. That can also means that you have other entities within this as well. It's just a fancy way to describe an object graph, and I've used this terminology in my database pesky N+1 queries presentation. So when we think of our repositories interacting with our entities, we don't create a repository per entity. We create one per aggregate root, because for those of you who have ever tried to create repositories that somehow describe, these levels of relationships, it gets pretty unwieldy pretty fast. So the general rule here in domain-driven design is to introduce a repository per itinerary. And this fits very well within our bounded context, because earlier when we were talking about those translation layers, well, I did say that could be a repository. Well, we know that meetups exist within this context. We know that itinerary exists within this context, and we know that E3 is also in here as well. But this bounded context needs to use it, so we could just go yoink, go to our repository and then fetch that information back for this domain right here. So repositories serve multiple purposes. They can be used within their own domain, or they can be pulled from other bounded contexts. Very powerful concept. And again, you can have multiple repository per entity. It's just very not recommended. It's a lot easier. It's a lot cleaner code, in my opinion, creating the queries and everything else to have one repository that manages those relationships for you. Okay, let's get back to the PowerPoint. And these are our strategies to get started fast. All right, so my closing thoughts. Whoa. So the trick to domain-driven design is always identifying your problem domains, communicating with your domain experts, refactoring, and then go to one. That's it. Domain-driven design is about refactoring at every level of the application, or every level of the design process or the implementation process. It doesn't matter. It's all about refactoring. It's refactoring your team. It's refactoring your models. It's refactoring your company. It's everyone working together to decouple, to segregate, to split out the problems that they're trying to solve, and then tackle them individually, sometimes concurrently, but still individually, and then so that way you can manage your complexity of your system. It's all about refactoring, all about taking the complicated and reducing it down to simple. I don't know if anyone's ever, heard of this before, but when we think of, simplifying things, it's hard. It's never easy. Whoever says that simplifying things is easy is lying to you, in my opinion. It's not. Simplifying's hard. Simple solutions are hard. So that's what domain-driven design is about. It's about refactoring until you get that simple solution to your problem. Wow. Okay. Let's move on to what do you want to do if you want to learn more. Well, there's this book. This is the book by Eric Evans, Domain-Driven Design, written in the 20s before the 10s. So the main book about domain-driven design is by Eric Evans. He kind of pioneered the whole concept. The second book I would recommend is this one, which we will be getting into in part 2 for more of the technical problems. This is kind of like an unofficial second book in the series. Well, it does say DD series, so I guess it is official. Implementing Domain-Driven Design by Val Vernon. I've heard great things about this. I haven't read this book yet, but that's going to be part 2. But I want to learn a lot more. So on this slide, I've included Domain-Driven Design and Implementing Domain-Driven Design. They're actual Amazon links, so you guys can easily buy those books themselves. Don't worry. If you purchase from Amazon, it's not going to benefit me in any way whatsoever. Tactical Domain-Driven Design by Peter Holmstrom. That was a really good article to read. It really went into some more of the implementation details, especially like revolving around validation. I don't exactly agree with his validation approach because he is throwing exceptions in his code, and I don't really think exceptions are the right way to handle validation problems. But that's a good article to look into. I found a YouTube video by Nick Shapasas. I can't say his last name, but he has a good video about using this library called Mapster, and I pasted that as a link right below at point 5. So when we're thinking about designing our repositories, we have to map our data to our entities some way, somehow, right? That's what 4 and 5 are about, and Mapster is a really cool .NET library for doing that. So highly recommend that one. The next one, Nested Types C# Programming Guide. So I was also thinking during my studies of this, I was thinking, well, what do we do if we're going to implement a published language? So a JSON library, or a JSON web client that are bound in context to communicate with. Well, if we want to implement that, what is a great way to serialize our objects to, well, JSON? One of the main issues being you could expose all of your function, or you can expose all of your fields through public getters functions, or just make the fields public in general, but sometimes you don't want to do that. So nested types within C# is a good in my opinion. I don't want to say it's the best, but in my opinion, I really appreciate the approach of nesting classes within classes. I've used this technique so many times in my code, and it's just fantastic. Patterns of Enterprise Application Architecture by Martin Fowler. What presentation on design, or what presentation, you know what, I'm terrible at speaking. No presentation on design is ever without a mention of Martin Fowler. So I have his book of implementation details of, patterns of enterprise application architecture. Not strictly domain-driven design, but he does go. But Eric Evans does have a good relationship with Martin Fowler, and they both together have kind of come up with technical solutions to that Evans brings up during his throughout his book to implementing some domain-driven design from a technical aspect. So good book of patterns. You don't have to use them. Use them where necessary, but good book of patterns. And that's all I got. Someone in chat asked how do you know when something is how something complicated is refactored enough to be simple, is basically the gist of what I understood it as. How do you know? I would say, in my opinion, a good indication of whether or not you know it's good enough is is the problem solved? B, can you reasonably understand what's going on with through your behaviors and interfaces just by looking at the function calls is really what it comes down to. I mean, it's a really subjective thing, honestly. It's kind of it's one of those things, and I know this is a crappy answer, but it's really one of those things is you know it when you see it. Yeah, that's all I have for that. Sorry, I know that doesn't really answer your question in the best way possible, but my rule of thumb: refactor at least 3 times. Make sure your code works. Refactor it, and then lo and behold, you have a simpler design just by doing it at least 3 times. Yeah. Oh, Levi asked a good question. Okay. So I'm sorry, someone asked Levi in chat a good question. So the question was, are there any existing repositories or code out there that kind of show a before and after? Yeah. Why don't I go pull one up real quick? Let me start Firefox. Let's see here. Oh, yeah, okay, we will just do that. Okay, so, right, so there is someone that I go to frequently. I think it's called Vlad, rich domain modeling. Oh no, this is trying to research valid. Val. Oh my gosh, I can't believe you guys are making me do this live search and I'm messing it up. Vlad. I don't know how to spell his name. Vlad. I think this is the guy right here. Wait, no. Oh, no, that's Martin Fowler. Was it Enterprise? Ah, this is the guy. Oh, no thanks. There we go. Vladimir. Sorry that took me so long, too. I'm sweating. Sorry that took me so long. This guy. Pluralsight, he has great videos about the subject. Each of his repositories kind of like goes into... he has a... Well, his Pluralsight videos also have like repositories... contain repositories where he kind of like goes into the like a before and after. I'm not sure if I can kind of pull it up here without like searching his GitHub or something, but this guy is a good person to follow. He has a whole bunch of content on the subject. So he's what I recommend. Look at his code. And then, of course, going back to the PowerPoint presentation, that tactical domain-driven design link, this was also pretty cool. So I know I'd already mentioned it, but this guy right here goes into a good... What is all these privacy settings? Whatever. What just happened? Okay, I don't know what's happening to my computer anymore. Maybe the link is bad. I thought I copied it right. Okay, here we go. Yeah, this guy, Peter Holmstrom. Yeah, so he kind of breaks it down. Not necessarily like a before and after like Vladimir does, but definitely has like examples. Like this is an example of a value object. This money class is kind of like a big, not really like a big, but kind of like the poster child of value objects, because of issues with IEEE 7754 with floating point number representation in binary. So you always want to have a money class when you're doing monetary calculations. So this guy and this guy are probably my two favorites right now, that actually have examples. There's plenty of others out there. Really, you just got to Google search for like, refactoring and domain-driven design. I'm pretty sure you can come up with a lot of stuff. So Levi asked me the question. Again, sorry for someone's asking Levi and Levi's asking me. He asked me the question: how long did it take to come up with a ubiquitous language with the domain experts? Depending what problem we're talking about. I've had meetings all day with our business to discuss like what problems we're trying to solve. So they're obviously going to be using different terminology than we are. because when they say claim it, we may say user or we may say customer, something dumb like that. So, or not even, or even something more technical. We might say like a specific type of user, a claimed user. Don't use that in the real world. That sounds like you bought them. But it's just little things like that that really I mean, I don't want to say like it slows down the process. It's just those little things of communicating with the customers or your domain experts about that you're just kind of like constantly. You just have to be aware of that. They may not understand your language. You may not understand their language. So it's always important to ask them to clarify, and then to be like, oh. So when you're saying, when we have a product and we have a customer, what we're really saying is, well, we combine those two things into a policy, right? They may think of it as something else than policy. They may think, well, no, it's still customer and product. And if you think of it that way, well, then you have to kind of adopt that into your own language as well and start thinking of it that way instead of trying to combine them into one policy. This is a terrible example, but I'm just trying to illustrate of what might happen when you're having these discussions. And if you ever like look at them, it's hard right now with COVID, right? Because if you're doing your meetings, you may not have that eye-to-eye contact. But if anyone starts looking like they have no clue what the hell you're talking about, that's probably a good indication to take a step back and to really explain what your intention is, and then try to understand what their intention is, so you can kind of adopt that language together. And it's also like really critical to make sure the rest of the team knows about this language too. We've constantly like working with this legacy system a number of years ago. We've had the same word that meant 3 different things. We had claim number, we had claim ID, and we had like, I think in this case it was just 2. It was claim number and claim claim number, claim ID. So yeah, even I'm tripping myself up on this because we had multiple names for this like single concept, and it was really terrible to try to communicate this back and forth with the business because they all knew it as claim number. We knew it as claim ID, or we knew it as also claim number, depending on the context. Because we used our like actual physical database IDs in some cases, and that's what we know as our translation. So working with other developers, that became a problem because like, oh, what's our claim ID? What's our claim number? What's our claim to claim? Yeah. It's always tough to explain these 3 different values all the different times, all the time, just depending on the context. So this is an example of a total failure in coming up with a ubiquitous language.